And I'd like to introduce Yingyao from GNRF Novartis here in San Diego, who will talk about Excel as part of their Cheminformatics interface.
So I'm going to talk about how we look at Excel more from an application developer point of view. So when we talk about writing Cheminformatics applications, we typically think of web-based applications like chemicalize.org or many of the standalone applications like Instant JChem we have heard about. But in the past UGMs, there are also several talks, and also including today, about using Excel actually as another programming platform. So Matthew and Thomas today all talk about all different advantages of using Excel as a development platform. So I don't really need to repeat that. I think they did a fantastic job in summarizing those. I just want to mention the second item. I say Excel is, most users consider Excel easy to use. I put a quote on use is because most users, what they do is basically open Excel file, I browse them, do the copy, paste, sorting. So most people consider that's what they do with Excel. If you ask user to see how many people know about pivot table, maybe not that many. If you ask how many people know how to hyperlink a cell, probably very few. So although there are many, everyone thinks they know how to use Excel. Actually, some of the Excel tasks actually could be quite challenging for many of the scientists. So from a developer point of view, the disadvantage of using Excel as a development platform, there are few, for example, there isn't out-of-box chemical intelligence. That's why we have JChem for Excel and many other plugin products. And I think a speaker, John, yesterday also mentioned the client he helped dealt with had a problem was because the Excel cannot handle those kind of fuzzy IC50 logic. We have to, in this industry, we have to deal very often, right? It doesn't know an IC50 greater than 10 micromolar is a numeric number greater than 10. It just treats it as string and all different kinds of consequences as a result of that. And also people in IT, many people probably are afraid of once we encourage Excel, we're going to create data silos, right? So people are going to keep data in Excel, not put into a company database, and you have data duplications everywhere. Performance issue, I think that's also from my own personal experience. Even I have a computer of 8-core CPU, but if you have tens of thousands of rows and then manipulating the columns, actually can still take quite a while. So it's not very scalable for a large data set. So at GNRF and Novartis, in the past 10 years, we have kind of developed a pretty nice comprehensive set of tools. So the nice thing is scientists in our company, they know they need to get the final process data upload into the company database if they want to share that data with other people, right? So biologists, if they don't upload data in the database, then chemists are not going to look at the data. So we are in a good situation, like all the process data, essential process data, they all captured in the company database. However, if you look at how those data were generated, right, so the upstream data still, most of those data are probably still captured initially within Excel. And because they're captured in Excel, so lots of data analysis are done within Excel. And scientists still, of course, Excel is the most natural format for people to communicate, to exchange data. So the bottom line is Excel is not going away anytime soon, right? So if you look at scientists, they spend lots of time. For example, they profile some compounds. They get a result in a spreadsheet, a column of compound IDs, some measurements, right? They often do is they copy this list of compound ID, find some web service, web program we provide to convert that, pull out some other IDs, pull out smiles, additional information, get another spreadsheet. Then they copy and try to merge that spreadsheet, into their original spreadsheet, right? That's something they do all the time. So scientists do spend lots of time within Excel, and some of the tasks they do are really kind of robotic tasks. And if you look at them, you really see there is an opportunity for us to do something to increase the productivity when they work within Excel. So we think about that. But however, we as a group, maybe many other people in the audience, we are okay with Java programming, C# programming, but many of us just don't want to touch Visual Basic or VBA to learn programming within Excel. So that's kind of a skill set many of us just not very keen in learning. So we had some discussion, and at the end, what we came up with is we assign one guy in a group. That person will spend the time to learn Excel programming in and out. Okay, so that person will write a custom Excel add-in. So the custom Excel add-in should do all the tedious work for communicating with Excel. Then the rest of the people in the group, they don't need to learn anything about Excel. They still focus on whatever their server-side, website programming. And this add-in, the job of this add-in is provide a wrapper. So whenever you write server-side function, you can publish that, and through the add-in program, it'll be available for scientists using Excel. So that's the main idea. So the presentation is about showing some slides and doing a demo to show you what kind of things you can do with our GNRF customized Excel add-in. And I'm going to show different applications, including, for example, how you can integrate existing web applications you already developed, integrate that with the data within Excel spreadsheet, right? So how do you do kinds of, for example, compound ID conversion? I mean, you have a list of compound ID. How do you, within Excel, how do you talk to complete database and pull out the smiles for them or do other things, right? How do you do in silico calculation without knowing, memorizing the ChemAxon formulas, right? So how do you launch structure search within Excel, and do a demo mostly focus on some bioinformatics application just to avoid the any IP issues with the showing some compound data. So first example is how do we integrate data within Excel with our web applications, right? Probably the most among all the web applications we have developed, the most popular web application is this one. We call it compound report page. It's actually a very simple web application. You put in a compound ID, it grabs all the data we have generated within a company and displayed it in a very compact, nice format. That's the application most often being most often used by scientists. So what happens is scientists have data within Excel, right? They have a compound ID. So in order to look at all the data we have collected, they copy this ID, open that web page, paste it in, do a search, and show the result, right? A couple of clicks there, okay? So what Excel add-in enable you to do is our add-in looks like this. When we have our custom Excel add-in installed, right, this is the Excel, then you see a panel of buttons and functions there. So what scientists can do is first they click on the compound of interest, then they click on a button called compound report, and then IE will just open up that page. There's no more copy pasting, no more bookmarking. So how it works is very simple. This button of the add-in, it knows this is the base URL it's going to do for the compound report page. When you click on the button, it's going to grab the content in that highlighted cell and put it into a URL. Then it just opens that page. So it's very, very simple idea. So you can do this with other things. For example, you can highlight smiles, then you click on the structure search button and you launch this application and just put the structure in there. So for example, I can show you this. Here are a spreadsheet of 6 known drugs, right, with some information. I will skip apart it. You can, I talk about that later. So for example, if I want to do a structure search on Gleevec, I'm going to highlight the compound ID, and I'm going to click on structure search. Okay, so it just go to a URL, which you can see with that compound ID at the end. So this is a web page, search page we created years before we had Excel adding. So we just integrate that without doing any customization. So this idea actually can work in some other interesting ways. So this is another example. You can be a little bit more creative. For example, this is a spreadsheet of some compound profiling results. So scientist has a list of compounds and profile it through a list of multiple assays. So these are the measurement results. So each cell actually, typically people will make multiple measurements, right, for a compound in an assay. So what we present here is an average IC50 value, okay? So if a chemist gets interested in this result, typically he will then want to know how reliable that result is. So each result is an average of multiple measurements. So the chemist will want to see the underlying dose response data, all the individual replicates, so to get a sense of whether that's a true result or it's a noise result. So, and underlying data is not something can be stored within this Excel spreadsheet, right? So that's where we load adding. What we do is scientists will click on this cell and then click a button called show curve. And this web page will open and show the underlying data. So this is the same trick, but then you'll say, how does it know, right? Because you're just highlighting a number. How does it know it opened the underlying data? So the trick is this spreadsheet is not, obviously it's not any arbitrary spreadsheet. It's a spreadsheet exported by our in-house instant JChem-like application. That's the spreadsheet most chemists use to look at the data. So what happens is you click on show curve, the adding will look horizontally and find the compound ID, and look vertically up and find the assay ID, and use those two ID to construct a new URL, and that URL will know how to go to the data warehouse to pull the relevant data. So that's the thing. So, but what I'm most interested in talking about today, actually, it's not about web page integration. That's kind of trivial, which we can all do. What I want to talk about is actually this autofill function. The reason I call it autofill is because very often what scientists do within Excel is you have, for example, you have a list of compound IDs, right? Then you need to copy it, go to some database, grab the smiles or some other attributes out, and put it back into the spreadsheet. So it's an autofill is a function you go from a column of data and can grab multiple additional attributes and automatically fill it out to go from here to there. And we try to do that just within Excel, okay? So what you do here is with the adding, you can highlight this column of compound ID. You click on this autofill button, you have a dialog. Okay, the dialog, you can tell the adding, I want to convert from compound ID, GNRF ID, and I'm interested in, for example, two additional attributes. One is smiles, another is the amount available for the sample. Then I click a button, I say start. Then I end up with these. So going from there to there, just a few mouse clicks, then it will automatically add two new columns and fill the data in the right cell. So I'm going to show the demo later. So the idea here is someone in the group load a web service which can convert a compound ID into smiles. Another person will write a web service which can take a compound ID and do something and report the amount available. So they publish these. They have no knowledge about Excel programming. They publish these for the adding. Then the adding will take care of that. So all the interactions with Excel are done by the adding. So the adding program, when you click on that start button, the adding program, this form, will talk to Excel to grab the list of IDs and then send that ID to the corresponding web service and get a result back, and the form is responsible for modifying the Excel spreadsheet to put the data back. So the program doing all the business logic on the server is not, it doesn't need to do anything about any Excel specific functions, right? So autofill essentially fetch data, invoke the corresponding web service, right? Get a result back in C# data table XML format and do whatever modification required. So that's kind of the architecture. And the reason is here I want to show a little bit more detail about this dialog form. The reason is we want this form to be so general that it can work with lots of different web services, right? So when people publish new web services, we don't need to modify the Excel add-in, okay? So the add-in form works like this. There's a first, you can choose which server you want to use, because GNRF is just one of the group within Novartis. There can be other group that provide their own service. So user can choose which server they want to use. Once you choose a server, the add-in will automatically ask the server to get all the registered web services. It understands all the web services, what they can convert, going from what column to what attribute. And based on that information, it automatically generates this GUI interface, right? So end user just go there and just tell the add-in, I want to convert from structure ID to whatever any of the available web attributes. Then this is a section we'll look at it in a demo. It's basically enable end users to tell the add-in how he wants to format the result data within Excel. Then he click on Start button and everything will work, okay? So I'm actually going to do the demo, and next two slides just a summarization of what I'm going to show next. So let's just look at the demo and let's see. So okay, so the first example we want to look at is if we have JChem for Excel, right? If I have a column of smiles, I want to do some statistical calculation. Basically, I write some formulas, right? So here, the other approach, what we do is I highlight these smiles. I say I want to autofill, okay? So I have a bunch of smiles. Then I want to calculate chemical names. I want molecular weight. I may want C log P in whatever order, C log P first, for example, okay? Okay, so that's what I want. So I click on Start. So the add-in will take this and talk to the server, get a result back, and that's what the scientist does. He doesn't know what web page can do that kind of conversion, and he doesn't know about any formula. Basically, there's no copy paste. I don't even use the keyboard. Okay, so that's basically, I think you kind of get the idea of what this add-in enable you to do. So, for example, here are 6 known drugs. So if the scientist say, now I want to search our vendor database, and if I want to do experiment, I want to see which compound I can purchase from some vendor database, right? So before, they will take each one of those structures and go through that structure search web interface and search the vendor database one by one, right? So what they can do is with the add-in, they say, I want to find out which smiles are in the vendor database. So I click on Start. So what this does, it actually takes each of the smiles and search the vendor database, and it gets a result back, and it tells the scientist the 4 structures are available from these vendors. And if you can see, it's very nice. It keeps all this is my spreadsheet. These are my data before, right? Everything is nicely still sortable. So here, some of you may ask a question, because for any particular compound, I only have one vendor. Maybe there are multiple vendors. Maybe the scientists want to pick a vendor they are particularly they have good experience with, right? So it's kind of one structure actually may return multiple rows, right? So how do we deal with that question, right? So first, we have a very nice undo. So let me undo. So I go back to where I were. I autofill. So this is where the formatting comes in. By default, I only keep the first row, but for example, I can keep up to 5 vendors if I want. Okay, so scientists do that. For example, we do another search. So we'll see. So this is what happened. For example, for Gleevec, okay. So there are 5 when it gets from 5. It keep up to 5 rows. Right, and as you see, it nicely duplicates all the data. The reason we duplicate all the data is because we always want a spreadsheet to be sortable, people to be able to manipulate that, right? So here, if the compound only doesn't have vendor, there's only the original row, nothing, right? So that's kind of how we deal with that. So now I'm going to switch and look at some other, for example, bioinformatics examples, okay? So often people give some data, bioinformatics data. They did some profiling for some genes. They give me some data for bioinformatics analysis. Very rare, people will give me entrance gene ID. And actually, gene ID, numeric gene ID, that's where all the bioinformatics database annotation associated with, right? So I used to spend lots of time. I get all different kinds of IDs, gene symbol, ref-seq number, clone ID, whatever. I spend lots of time to convert that into some entrance gene ID that I can manipulate with my bioinformatics tools. But now with the adding, life is now pretty simple. So even as a programmer, I don't want to write programs. So here I choose another server, which is actually resides in Switzerland, because we have a commercial bioinformatics database there, which has most of these curated information. So I say, now I have a list of gene symbols. Okay, so I have a list of gene symbols, right? Then I want to grab a list of entrance gene IDs. So I click, so it'll send the result to Switzerland and get the data back, right? I get a column of gene ID. Normally, imagine how biologists are going to do that. They're going to copy each symbol, go to NCBI page, do a search, find the ID, paste it back. But even for people like us, we still have to write little scripts and to do that, right? So once I get a gene ID, I can do a lot more stuff with that now. So I have the gene ID. For example, just to double check, I'm going to grab the symbol again to double check I did it right. I grab the description, and I grab the organism to make sure all these are human genes. I want to have some biological annotation, for example, okay? So I hit again. So again, it talked to a server. Okay, I get all the result back, right? So these are the result I need. So all within Excel. Now the other thing is, for example, imagine the biologists for these genes, they run their profile in a particular assay in-house. They get some activity data. So hypothetically, that biologist also send these genes to a CRO company, right? The external company will help them profile these genes in a different assay and get a result. And then they receive the result back. The external company already sort the result alphabetically by the gene symbol, right? And now the biologists now need to merge these two, right? And in this case, it's not that difficult. You can sort these two columns and merge. But in a more general case, the number of entries in these two tables are different, right? And all different things. And try to do that join within Excel. It's not that easy. And not many scientists probably doesn't know how to do this. if it's just 6 entries, they'll probably do it by hand. If it's more, it's difficult. So we realized that. So this is what we do. I go to our autofill. Okay, I switch back to the server, to our own GNRF server, because this server, we have a web service providing functionality. Okay, so I say I want to do a table join. So I first select the first table. This is a table. Okay, I want to merge with the other table I got from the external party. Okay, so I want to do a join with these 2 columns. First column. Okay. So I get a new spreadsheet with everything merged. Okay, I think my time is up, right? So it doesn't really matter. I have another demo which it's not essential. So another demo is show you actually you can run some very sophisticated algorithm, data analysis method. So make it available to people within Excel so they feel more comfortable to use. For example, you may implement a clustering algorithm on a server. Then this add-in does is fetch the whole spreadsheet, send it to server, get a result back, and put it into Excel. So here I was planning to show some algorithm which can do some bioinformatics hit-picking analysis and get a result back. But I think probably people already got the idea what kind of this add-in can do. So just to summarize, so I show you an example. If it's possible to design a kind of general add-in program and serve as a wrapper so that most of programmers in in-house or you have web applications, they don't need to be aware of the Excel particular programming environment, and they can make all these calculations or web page accessible to people, scientists that are familiar with Excel, and to simplify their learning curve and make them more productive. So, any questions?
Any questions? We want to thank Yingyao for that talk. It's actually very, very impressive.
I'm very impressed that this magic work you have put in the spreadsheet. I have just a question about this accessibility. Do you have any control of who can access the compound structure?
Sure. Because these are web service, right? So if you send the smiles, of course, you already know the structure. But if the service is, I say I want to convert from compound ID to smiles, because that's a web service, your identity is there. So it's all checked by that. So if you don't have access, the service will not return smiles for that compound ID. Right.
Just a quick question. What kind of deployment model do you use with your Excel add-ins?
What kind of deployment? The add-in is just like JChem for Excel. It's just usually IT will push out. Then when people reboot their Excel, that add-in will be installed. So the nice thing about the add-in only installed once, and whatever new web service or server side, when we fix Spark, when we add new functionality, usually there's no installation. Yes, we actually use that. Right, but the IT has a way, even user doesn't need to explicitly click on the setup file, click once or whatever. Yeah, but click on once, yes, you have a new update available, right? Then yes, when people relaunch Excel, it'll pick it up. But we haven't updated this add-in for about 6 months now, because all the modification will be done on the server most of the time.
Okay, I wasn't quite clear how the autofill was working, but it looked to me like you were grabbing the data and then inserting those values into the sheet.
Right.
Is that correct?
Yeah.
Did you consider the alternative of using a function in Excel to do the retrieval, which I'd have thought would allow the data to be kept in sync much better than by inserting the raw values in? Yeah,
I mean, yes, you have that advantage of keep it in sync, but you have the disadvantage of educating end users to learn all different functions. And you have the disadvantage of asking some of us is not a big fan of programming within Excel to implement a function there.
Well, what I was meaning, you autofill could insert the function, not the value.
Yes, but most user probably, I mean, for smiles for compound probably doesn't change. Yes, even your function you save in a spreadsheet, it may be obsolete. Yes, you have a good point. Every solution has the advantage, disadvantage. I think in general, this in most of cases, I think it works well. Say that again. Sorry, I missed the first part. Yeah, the result come back as a result as a numerical value stored there, so you don't recompute. Then depends on the service. If the service can only take one smiles, then the add-in will send one structure at a time. If the service sometimes can take a batch, it can do the batch to make it faster.
Any other questions? All right, well, we'd like to thank Yingyao again for that presentation. That was actually, once again, very impressive. Thank you.